Okay, we're going to get started with our conversion and density lab, pre-lab. I have the pre-lab projected onto the board. You're not going to be able to read from that. What I'm doing is showing it so that you can see how to graph this. What you should do instead is print out or have open the pre-lab document, and you're going to be then writing into that. If you don't have this piece printed out, then find a space where you can have a grid like this that you can use for this graph, okay? So as we go through the video, I'm going to compare this data that we have here. We're going to put it into this graph, and you're going to be required to graph for your density lab when you write up the questions. So we're doing a little bit of a tutorial as the pre-lab. You can see that the data we have is a description of water lost in a leak. When you read that, there's a leaking faucet, and the rate of the leak changes throughout the day depending on the temperature. And we're going to graph that and then come up with a slope for our line in the end. I have some descriptions of what you need to do in order to correctly graph this. We're going to start with a title. The title for our graph should describe the information that's in the graph. And that title, we're going to write over the graph itself. So for this, we've got water lost over time. So that's what we need to use for a description of this. It should include what we have for the x-axis and what we have for the y-axis. Our x-axis is time and our y-axis is water lost. So we're going to choose a title, water lost versus time is a way to do that, or time in hours. So my graph or something like that is not an appropriate title, but if you describe the x and y axis, that's a good way to go for titling your graph. The next thing is to correctly label the x and y axis with appropriate increments. If you look at the last page of this, or sorry, the last sentence in your starting paragraph, it says that time is our independent variable and is placed on the x-axis, and the amount of water is on the y. So for the x, I'm going to put time, and our units, our increments are hours. The y-axis is water lost, total water lost. And the units, which are written here, are in mils, ml. So we put our units into parentheses to show what is being measured there. The next step is to write the increments. So what we want to do is look at our least and our greatest value. So we'll start with time. Our least amount of time, we have a measurement of the water loss versus time, and it goes up to 24 hours. So an important piece here is we want to use the actual graph that we have. So we're going to count out. It would be great if this is 12 increments from 0 up to 12. Then we could use 2 for our increments. But let's count. If this is our 0, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can't use 2. Let's go ahead and use 2.5. We're going to start with a 0 here, and I'm going to mark every other. So this is 5. That means that this line is 2.5. This next one would be 10, 15, 20, and 25. So we want to make sure that those accommodate all of the data points that we have up to 24, and they do. For our y-axis, we want to look at the increments that we have. We need to go above 258. So we're going to check and see. I think if we go by 25, so 25, 50, 75, 100, 25, 50, 75, 200, 25, 50, that will just get us there. So, so these are going to be 25 increments of 25. And I'll pause and let you fill that in. Okay. So now we've got our increments 0 through 275. for our water loss that accommodates all the values we have, and then we have our time that will accommodate up through 25. Next it says graph the points with obvious markings. So we have a point that is 0, 0, 0 in terms of our water loss and in terms of our time. So we're going to graph these points. Remember that if you don't have a 0, 0 data point, do not put that as a point on your graph. In this case, we do. Those in green. So we do have a 0, 0 for this. We also have a 6 hours. So if this is 5 and that's 7.5, then 6 is going to be right about here. 6 hours versus 50. We have a 12 hours. So if that is 2.5, 12 hours versus 120. So that will be here. We have 18 hours out here versus 165. I'll be up here. And we have 24 hours versus 258. So 24 would be about here, and then 258. So go ahead and pause and get all of your increments filled in. Make sure you have those. You might want to use a pencil just in case you get some markings off. So now that you have your obvious markings, so not just a dot with a pencil, but obvious points on your graph that are these data points, we're going to use a ruler to add a line of best fit. So I've got a meter stick here since I'm working with this, and you should be using a ruler or a straight edge for your line of best fit. Now, because these are somewhat of a line, we're not going to use a curve, and we certainly don't connect the dots here. We're going to show a line that fits the data. So you kind of look to see data that you have above and below, and put in your line of best fit. So go ahead and do that. You might need to pause the recording. You can see that I have some of my data points above and some below. And that would be this making the graph part of the line. So complete that, and then pause if you need to, and then come back when you. Okay, so now we've correctly completed a graph. Hopefully yours looks similar. And now we're going to go to the questions that are written below. You can't read them on the projector, but that's fine. They're written on your sheet. The first one is, what is the equation that you should use to find slope? Now we know that slope is rise over run, but that's not actually an equation. So the equation is going to be our change in y, that's our rise, divided by the change in x. So the equation is that the slope actually equals whatever point we have, y2 minus y1, divided by the x value, x2 minus x1. Okay, so that's your equation. For number 2, we're going to circle 2 points on the best fit line. They probably won't be data points, or very often they won't be data points. We'll use the slope, or sorry, we'll determine the slope using those 2 points in the equation above to find the slope value. Then we'll give the value for the slope, including units. We're going to show work. So I'm going to find 2 points, and with a different colored pencil, I'm going to circle those points on my graph that I'm going to use. Okay. So this point has, and the nicest way to use this is to actually find a place where it crosses on the grid. So this is point 25 to 50. Okay. My line just happens to cross there. This one crosses at 5, that's my x value, and 50. Okay. So I'm going to plug that into the equation for my points. I want you to circle 2 points of yours and then describe what those x and y values are for those 2 points. Okay, so I've identified my 2 points. I call this point 2 and this point 1. And I put those values into my slope formula. So y2 is 250. I subtracted 50, the y1 from that. And x2 is 25, and I subtracted 5 from that. So when I come up with a value, I get 200. That's 25 divided by 50. And then I got a value of 20. So I can either plug that into my calculator, or I know that when I divide those, that I'll actually get a 10, but that's only the value. It doesn't have any units associated with it. So if what I'm looking at is a y divided by an x, then I need my units for y, which are mils, divided by the units for x, which are hours. So we can see that that means that the slope is telling us we've got a value of 10 mils per hour. Question 3, I'm not going to write the answer down for you. You need to think about this. What is that telling us if we're looking at water loss versus time in hours? That means that we're looking at the value over a period of time, and it's telling us 10 mils per hour. So I want you to respond to what this line represents. What is that telling us about this leak? Okay, finish this up, take a pic of it, and then turn it in as your assignment.